So today we're going to be learning about graphing systems of inequalities. So let's look here at these definitions first. So the solution to a system of inequalities is the set of ordered pairs that satisfy all the linear inequalities. So remember when we graphed lines, the point of intersection was our answer, right? Like wherever the graphs met, or sometimes we'd have a graph that looked like this, and then maybe we'd have that U shape, right? And so the answer would be here and here. But in this case, it's going to be different. So there's actually going to be an infinite amount of answers, and we'll get to that. So the solution can be shown by graphing. So step one is to graph and shade each linear inequality. So there's two for each one. And then the solution, or the answer, to this system is where the shading overlaps. Okay? So let's take a look at the first one. So the first thing we have to check for is to make sure it's in y equals mx plus b, which both of these are. So remember, the -1 is your b, your y-intercept. So I'm going to go down 1, and then this -2/3 tells me to go down 2 to the right 3, or I could go up 2 to the left 3, but we're going to go down 2, right 3, down 2, right 3. We could also go up 2, left 3. And then remember that the inequality, that tells you it's going to be a solid line. So try that one more time. So it's going to be a solid line. And then we have to shade this one. So I would shade as you go. So let's shade this one. This one says this is less than or equal to, which means we're going to shade below. So I'm going to shade this way. So that was your last lesson. That's all you had to do. But now we're going to graph another line. So we're going to go down 8, 4, 5, 6, 7, 8, make a point. And then we're going to go rise over run. So rise 1, run 2, run 2, rise 1. So even though they intersect there, that is not your answer. You're going to draw a solid line, and then you're going to shade. So this sign tells you to go up. I'm going to do it in a different color. So we'll say it's going to be this way. So everything above, right? Everything above that line. And by the way, if this line continued, it would go all the way down here, right? So that means that this is still considered above over here. That's why. Okay, where do they intersect? So I'm going to do this. Let's do it with black to make it really obvious. So where they intersect, which is in this area, that is your answer. So I want you guys to shade that really dark. So this right here is your answer. Everything right here. That's your answer. Okay, let's do number 2. So number 2 is also in y equals mx plus b. So we're going to go down 4 on the y-axis, make a point, and then we're going to rise 3 and run 4, rise 3, run 4, and then make a point. I'm also going to go down 3 and to the left 4. It's important you guys make a lot of points on this, even though before I think for lines I only had you draw 2, because it needs to stretch across the whole graph, because we're shading now. And then because it's less than or equal to, we're going to draw a solid line. And then that sign also tells us to shade below. So we're going to shade this way. And then we're going to graph the next one. Remember, y is greater than -7. So we're going to graph a y equals 7 line. -7, which is down here. And that tells us it's going to be a dashed line. So it's going to look like this. And then this tells us to shade above because it's greater than. So shade above. And then wherever they intersect, wherever they meet, is your answer. So your answer is this section right here. And then make sure on your test you make it really obvious. Make the dashed line right there really obvious, and then make the shading really obvious too. Okay, this one we need to get the y by itself. So I'll do the top equation over here first. So x minus y is greater than 1. I'm going to subtract x from both sides. And then I have -y is greater than. I'm going to put the x term first. And then I have to, there's a 1 in front of this y. So I have to divide by -1. Now remember, when you divide by a negative number and you have an inequality, you have to switch the sign. So it's going to be y is greater than. Oh my gosh, I didn't switch it. Less than. So it's going to be less than. So you're going to flip that sign. And then here, a negative divided by a negative is a positive x. And then a positive divided by a negative is a negative, and then 1. Okay, so let's graph that one. I'm going to go down 1. And remember, this is a 1 in front of that, so it's really like 1 over 1 for the slope. So rise 1, run 1. I'm just going to keep going up here. And then this is going to be a dashed line. So I'm just going to do this. And then shade. So this tells you to shade below because it's less than. So I'll shade in this direction. And the next line. So here, if we have x plus 4y is greater than 20, we're going to subtract x from both sides. 4y is greater than negative x plus 20, and then divide by 4. So y, and this time I didn't divide by a negative, I divided by a positive. So I'm going to put negative 1 over 4x, because remember, up here, that's really a 1 in front of it, right? So you can take the 1 out and make it negative 1 over 4x plus 5. I'm going to box that one because it's hard to see with that line. So you're going to go up 5, and then you're going to go down 1 to the right 4. Down 1 to the right 4. And I'm also just going to go up 1 and to the left 4. You guys will have to let me know what you think about video notes. I think, yeah, I've given you video notes when I've been absent before. But I feel like some people were mentioning that in the survey, that they like video notes. Like Mr. Harris, if any of you had him for Algebra 1, did video notes. Well, it was like a self-paced class. So you have to let me know. Okay, that is greater than, so we're going to go up. And then we're going to shade where they meet, which is right here. And that's your answer. Okay. How many do we have? Okay, so number's 4. Let's do number 4. And sometimes it's good to switch it up. So even if we don't do video notes all the time, because I know some of you guys just learn better in person, and some of you like to learn independently. So I might be able to do this, I don't know, once a week, once every 2 weeks, even if I'm at school, so that way you guys get some of this. So just, we'll talk about it on Friday when I get back. So you're going to subtract 7x from both sides. You have 3y is less than or equal to negative 7x plus 18, and then divide by 3. So y, again, we did it by a positive 3, so we're not going to switch the sign, and that's our answer. And if you need to also, you can pause and rewind if you are spacing out, which is something you can't do when I'm teaching, so I know that's really nice too. So go down 7 and then to the right 3. Down 7 to the right 3. Okay. This sign tells you it's going to be a solid line. So I'm going to try to connect these the best that I can. And then the less than sign, because that says less than or equal to, tells you to shade below, which is below is here. So it's going to be all on this side. And honestly, I'm going to erase all of this. So if you need to pause it and finish copying, but I'm going to erase this because I can, and it makes it easier. So here, I'm going to subtract 2x. I have negative 3y is less than or equal to negative 2x plus 9. And then I'm going to divide by negative 3. We're dividing by a negative here, so we're going to flip the sign. It's probably one of the most common mistakes because you're used to an equal sign. So make sure you remember here this needs to switch. And then negative divided by a negative is a positive, 2 over 3x. and then a positive divided by a negative is a minus, or a -3. Okay, I'm going to go down 3, rise 2, run 3. Again, that would normally be your answer if you were graphing without shading. And we graph without shading when there's no inequality signs. So you see how this is an inequality sign right there? When it's just equals, if it was y equals 2/3 x minus 3, then that's when you do the point where they intersect. Okay, if you have two lines with equals. But here we just have two lines with inequality, so that's when we shade. But we graph and do everything else the same. Okay, so this is greater than, so we're going to go up. And where do they meet? They meet here, so that's your answer. So always make sure to shade this in a lot darker. Okay, number 5. We'll do the first one over here. So x plus 2y is less than -6. I'm going to subtract x from both sides. 2y is less than -x minus 6. And then divide by 2. So we didn't divide by a negative, so we're not going to flip the sign. I'm going to take this 1 that's in front of that x, I'm going to take it out. So I'm going to take that whole fraction out, so it's -1/2 x, and then -6 divided by 2 is -3. So I'm going to go down 3 on the y-axis, and then rise over 1. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and then up 1 and to the left 2. I did video notes last year for all my students, but I feel like, and then we're going to do a dashed line, because there's no equal to. But I feel like people started getting lazy because we did them too often. We did them every day because they really liked them. But then the students I feel like started just, I don't really know what happened. Then by the end of the year, they wanted to do regular notes. So I think it's just good to switch it up. Okay, this says less than, so we're going to go down this way. Okay, and then let's do the next one. Again, I'm just going to erase all this. So this time I'm going to add 4x to both sides. -2y is less than 4x plus 10. Oh my gosh. 4x plus 10. No, not plus 10, minus 10. And then divide by -2. I divided by a negative, so I'm going to flip the sign. So y is greater than 4 divided by -2 is -2. -10 divided by -2 is a +5. So we're going to go up 5 and then down 2 to the right 1. Down 2 to the right 1. Because remember, this is -2 over 1, right? Which tells you down 2 and to the right 1. And then there's going to be a dashed line as well. And then which way do we shade? This sign tells us to, do we flip it? Yes, we did. To go above. So we're going to go this way. Okay, now in this case, they only meet, because actually if I would have went all the way down, they only meet right there. So right there in that little section is where they meet. So in this case, like if you were to show me this on a test, I would really make it obvious that you know that this is where they meet. This is another reason why you need to go all the way down with your lines. Because if we stopped here, you would have, I don't know what you would have wrote, to be honest, no solution. But there is a solution, and it's down here. Okay, so make sure you write that. Okay, I'm going to graph the bottom one first because I don't need to solve for that. So that's x equals -1, which is on this side. I'm going to draw a dashed line going like this because that is the x equals 1 line, but we do a dashed line because there's no equal to sign on the bottom. It's just a less than, and less than tells us to shade to the left. And then I'm going to do the top one down here. 4x minus 5, y is greater than -5. And then minus 4x. So we have negative 5y is greater than negative 4x minus 5. And then I'm going to divide everything by a negative 5. When we divide by a negative, we flip the sign. So y is great. Oh my gosh, why do I keep doing that? Less than. So this flips. A negative over a negative here is a positive 4 over 5. And a negative divided by a negative here is a positive, and then 5 divided by 5 is 1. So we're going to start at 1, up 4, over 5, make a point. I'm also going to go down 4, to the left 5, make a point. This gets a dashed line again. And this sign tells us to go down. So we're going to shade this way, and they meet here. All right, next one. Next one is a word problem. Oh, no, it's not. Okay, 8 and 9 are. So which points are solutions to the systems of inequalities below? So we have lots of different options here. How do we figure this out? Okay, so what we're going to do is plug them in and see if they fit. So this is going to be a lot of math. So, work that you're going to have to show. So I'm going to start with this one. So if I plug 1 in for x and 1 in for y, I'm going to see if that's a true statement. So 1 minus 6 times 1 is greater than negative 48. Okay, 1 minus 6 is negative 5, right? Is negative 5 greater than negative 48? Yes. Okay, remember on a number line, if we have negative 48, it's going to be all the way down here. Negative 5 is going to be like over here, almost at 0, right? So that's a true statement, but we also need to see if it's true for the bottom one. So we're going to say 2 times 1 plus 3 times 1 is less than 9. So 2 plus 3 is 5 less than 9. That's a true statement. So that is going to be one of them. I know what some of you are thinking. You're thinking this is a lot of work for one problem. Okay, let's do this one. So 9, negative 2. So 9 is going to be plugged in for x. Minus 6 times negative 2 is greater than negative 48. So 9, and then negative 6 times negative 2 is plus 12. Is 9 plus 12 is 21. Is 21 greater than negative 48? For sure it is. So the first one works. Let's try the bottom equation. 2 times my x is 9. My y is negative 2. So 18, 3 times negative 2 is negative 6. Is 12 less than 9? No. So that one does not work. Okay. I know I'm going kind of fast, but this is just plugging in numbers, right? So this one. If I plug in 3 for x, so 3 minus 6 times my y is 4. So this is, sometimes they're obvious, like this is going to be greater than negative 48 because 3 minus 24 is negative 21, and remember with negatives it's the opposite. So negative 21 is greater than negative 48. I'm going to plug it down here. 2 times 3 plus 3 times 4 is less than 9. Okay, well 6 plus 12 is not less than 9. We don't even have to keep going, right? So that's not true. So I'm also going to cross that one off. Looks like that's a negative 2, right? So negative 2, 6. Let's try that one. And then for the word problems, we're not even going to do B, and we're not going to graph, so we're almost finished. Okay, so we're going to plug in negative 2 for x, minus 6 times y is 6. Negative 2, that's negative 36. And then that's negative 38, which is also greater than negative 48. That's a true statement because it's negative. And again, on the number line, negative 48 is over here. Negative 38 is somewhere over here, and 0 is all the way over here, right? So that's closer to 0 than negative 48. So that's true, so we have to keep going. I'm going to plug in negative 2 for x. So negative 4 plus 18. Okay, well that's not going to be less than 9 because 14 is not less than 9. It's not true, which means this is not true. All right. Let's try the next one. So x is negative 8, y is negative 3. So negative 8, negative 6 times 3 is a positive 18. Well, that's going to be a 10. And is 10 greater than negative 48? Yes, absolutely. So let's do the bottom equation. We're going to plug in negative 8 for x and negative 3 for y. So negative 16 minus 9, that's negative 25. And that is less than 9. Cool, so that one works. And last one. 4 minus 6 times negative 7. 4 plus 42, and that's for sure greater than 48 because that's going to be 46, right? And then 2 times 4 plus 3 times negative 7. 8. 3 times negative 7 is negative 21. And that's going to be a true statement because that's going to be a negative number. So that one works too. Man, I feel like I went through that really fast, but I feel like hopefully you know what I did. I just plugged in x and y and solved, which means I just did 12 problems pretty quick. So hopefully that you caught on to all that. If not, you can ask me on Friday. Okay, last ones. So to raise money to attend a Boy Scout camp, Alec is selling popcorn. Small bags of popcorn sell for $4 and large bags sell for $6. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags total of any combination. Okay, I want you to look back up at our problems here. How many equations were in each one? There were 2. 2 here, 2 here, right? That's why we're doing systems of inequalities, which means they're going to have that black space that you see all over the place here. That's our answer, right? So we have 2 equations here. So we're going to have 2 equations for these word problems. So the first part is right here. It says small bags sell for 4. So we have 2 different pieces. Just like before, we have small bags and we have large bags. Okay. Small bags sell for $4 each. So $4 depending on how many you buy is the x. So like if we bought 3, it'd be 4 times 3. We just spent $12, right? And, which means plus, large bags sell for $6 each. We're going to put a y next to that because we said y was for the large. He needs to earn at least $300, which means that this side needs to be at least or greater than or equal to 300. Because if he doesn't raise at least 300 here, then he's not going to be able to go to camp. He will also earn a badge if he sells at least 60 bags total of each combination, which means he could sell, I don't know, let's say he sold 12 large bags. That means he would, let's say he sold 12 small. That means he would still have to sell 48 large, right? Does that equal 60? It does. How am I going to write that equation then? Well, I'm going to make, we don't know if it's going to be 12 small. I just gave you an example. We just have to equal 60 bags. I don't know. You could have any combination. You could have had 13 small and 47 large, right? As long as they equal 60. So my point in this is going to be our other equation. We're going to have some amount of small bags plus some amount of large bags. And he also has to sell at least 60 bags of popcorn. Like I said, that could be 12 and 48. It could be 10 and 50, right? But he has to sell some amount to make 60. And that's all we're going to do for 8 right now. We're going to do the graphs on Friday. Okay, Greg needs at least, there's that word, 160 in stamps to mail a package. He has 28-cent stamps and 4-cent stamps. He can use no more than 24-cent stamps as he only has 1 book left. So he needs at least 160 in stamps. Okay, so he has 28-cent stamps and 4-cent stamps. So honestly, we'll just say, I don't know, X is stamp 1. It doesn't really tell us. It just tells us, we'll just say stamp for 28 cents. And then we'll say Y is the stamp for 4 cents. Remember, 4 cents is 0.04 when you put it in a decimal, right? It's like 4 pennies. Okay, so he's going to have 28-cent stamps plus 4-cent stamps, and he needs at least 160 in stamps, which means it's going to be greater than or equal to 160, because at least is always that greater than or equal to, because it has to be at least, or that number or more, right? He can use no more than 24-cent stamps, as he only has 1 book left. So he can't have more than 24-cent stamps. Okay, this is how we write this. Y, and then we know that there's going to be 20, right? He can't have more than that. But he can have 20. He just can't have more than that. So that's going to be your other equation. He can have no more than 24-cent stamps, which means Y has to be less than or equal to 20. He can have 20, and he can have less than 20, but he cannot have more than 20. Why did I choose Y? Because Y represents the 4-cent stamps. So this is like saying 4-cent stamps has to be less than or equal to 20. Okay? And if that doesn't make sense to you, I will re-explain it on Friday. Try your best to do the word problems. You don't have to do B, like it says on the board, but you have to try A. Just set it up. I know it says then graph, but we're going to graph it next time. Okay? So try those.